So we're going to continue in chapter 2 on functions 2.2. The learning targets are I can find the domain and range of a function from its graph. Talk about the x values, the domain, the range, y values, the range. I can write the equation of a piecewise function by looking at the graph. Then we'll get into looking at the vertical line test to determine if a graph represents an actual function. I can determine whether an equation actually represents a function. Is an equation actually a function? And then making use of the graphing calculator, the TI-84 or 89, to graph a variety of functions. Okay, so first we'll look at this piecewise function that I have down, and we're going to actually write, look at the graph, and we're actually going to find the values of y when given the x value. So all these over here, where they're giving us f of negative 2, f of 0, f of 2, and f of 4, those values, it's in function form, those are the x values. And so if I say, okay, at what is y when f is negative 2? So if I go to the graph, here's negative 2 here, trace it up to the graph, and over, it is a value of 2. How about f of 0? F of 0, that's the x value 0 here, I trace it up, and you can notice there's a solid dot there, which is the very important dot, which is 4. F of 2. Trace it over. Here's 2. Now, I see this dot up here, but that's open. Don't include it. It's not included. So the one that's solid here, 0 is good. I'll erase it so you can see it. It's solid there, so that one is good. Then f of 4, the x value of 4, trace it up, and over is at 1. Second part of this says, what's the domain? Now, our domain is our x values. So these are our x values. Now, if I look at the graph to the far left and the far right, this graph is going to the right forever, and it's going to the left forever. All right, so let's keep that in mind. It's going to the right forever and the left forever. So what does that give us? The domain, negative infinity to infinity, an interval notation, and I use parentheses on those. For the range, a little bit different. The range, it does go down forever, and then it stops, it goes up and stops at 4. Let me just point that out on the graph. It is done right there at 4. All right, so the range will be negative infinity to 4. And it's a bracket at 4 because it actually includes it. Now I want you to think about that for domain and interval notation. We always think about it going from left to right. Range is always bottom to top. It's very important. All right, bottom to top. Okay, so it says, let's write the piecewise function for this graph. Okay, so let's do that. It says we have 3 different functions. So here's a couple things, and I'll put this in the directions. That when the graph changes, I put dotted lines, and that's what those 2 red dotted lines are. All right? Let's write the equation of the first one to the far left. It's a linear equation, the form of y equals mx plus b. All right? So y equals mx plus b, where m is your slope and b is your y-intercept. Let's take a look at the slope. Slope is rise over run, up 1, right 1. So up 1, right 1, up 1, right 1. So far the slope is just 1x, which is just x. And the slope, or excuse me, the b value is your y-intercept. Looks like it crosses right there at 4, so plus 4. So our first equation is y equals mx plus b. All right, and I don't need the y equals because I have the fx there. I'm just going to erase that. I have x plus 4. And that is good for, move these over. Ooh. That is good when x is less than or equal to 0. All right? Why is it x is less than or equal to 0? Well, you can see this line, this first line, goes up, and when x gets to 0, it stops. And it's solid there, so we actually include it. That's why it says less than or equal to, x is less than or equal to 0 there. So it includes the actual 0. In the middle, it's a parabola. Now, it's in the vertex form, so I'm going to write the vertex form. Y equals, if you remember this from Algebra 2, or FST, a times x minus h, quantity squared, plus k, where h and k was your vertex. All right, so it looks like this one, the vertex is peaking out at 0, 4. So the vertex is 0, 4. The pattern of change, if you look at the parabola in the middle, it goes right 1, down 1, write 1 down, 1, 2, 3. So the pattern of change is -1, -3, and it would be -5 if we needed it, but we don't. All right, so what's that give us for the equation? Y equals A, in this case it's -1, so it's 1, negative, x. The h value is the x value of your vertex, in this case it's just 0, squared, and then k is the y value of your vertex, in this case it's just 4. So the equation that I'm going to put up above is -x, I'm going to put it here and slide it up, -x squared plus 4. Let's see if that makes sense. It says that is good when x is between 0 and 2. 0, not including 0, that's what this open circle means, and then including 2, it is solid. Finally, the last one, again, it's linear. I need the y-intercept. I can tell that the slope is up 1, left 1, so that's going to help me out with saying that's a -1 for slope, so -x. And then my y-intercept, if I just continue to trace it, looks like the y-intercept would be 5, even though I don't need it on this one. So -x plus 5. And let's see if that makes sense. When x is greater than 2, so not including 2, it's an open circle. Let me just see if I can clear it there. Yep, it's an open circle right there at 2. And then it goes on forever. All right. Keep in mind, at 2, it's solid at one place. It's solid right here and open here. It has to be like that if it's going to be a function. All right. If it was solid in both places, we'd have the same solution for the value of x at 2. That makes not a function. Let me just go to some directions about how to graph a piecewise function. Draw vertical lines where the piecewise function changes. That was my dotted lines. If you go back, that was my dotted lines on this graph here. All right, those 2 dotted lines. Number 2, graph the first function stopping at that line. All right, to find where to stop, evaluate the first function at x equals the value where the change occurs. You don't have to actually do that, but if you just know that that's where it's supposed to stop, you know where it's supposed to stop, then do that. But what this number 2 is saying, x equals the value where the change occurs. Well, on this one, the value changes at 0. All right, so what this is saying, to find where to stop, evaluate the function at x where the value is supposed to change, 0. Make a decision. Is it open or is it closed? All right, take a look. Is it open or closed? X is less than 0. So for this one, it should be open. All right, because it's only, it's less than or equal to. Let me say that again. I had it covered up. X is less than or equal to 0. So this one would actually be solid. It's actually a closed dot. That's actually a closed dot. All right, so that's the decision that you're trying to make. Between the 2 dotted lines, you can see x or 0 is less than x, less than or equal to 2. So at 0, it's supposed to be open for this parabola. And then at 2, it is supposed to be closed. Make the decision based off those inequalities. 3, graph the second function. Starting at the line, to find out where to start, evaluate the second function at that x value, where the change may occur. And you might need to lightly grab to the left of the vertical line to get an idea where the graph is going. Or you can make a table using values greater than 2. What I do is I say, yep, let me just lightly make a line to see where that line is actually going. I actually did it on this equation right here. I dotted this line to see where the y-intercept would be at 5. Finally, repeat the process if there's another piece to the function. All right, so if there's 3 parts, do it again. Okay, so let's graph this function. All right, I have a vertex, a vertex form equation, and I also have a linear equation. So I have a parabola, or quadratic in the vertex form, and a linear equation. So the one in blue, I'm just going to put down some information. What is my vertex? Our vertex is 0, 1, and I get that right from the equation. All right, there's no h value, or there is, but it's just 0, and my k value is 1. The pattern of change, since that a value is negative out front, it is -1, -3, -5. All right, so let's graph that. All right. The vertex is 0, 1, so I'm going to put a point at 0, 1. And I'm going to trace that. Oh, my first step was at 2, there's a boundary. So I put a dotted line right there at 2. All right. That's just telling me that's where my graph changes. All right, so now it's graph of a parabola. All right, x is less than or equal to 2. Okay, great. So everything to the left of 2 is good for the parabola, the equation in blue. Vertex is 0, 1. My pattern of change is -1, -3, -5. Right 1, down 1. Right 1, down 3. 1, 2, 3. I have to make a decision. Is this point solid or is it dotted? It should be solid because this is less than or equal to 2. I can graph the other way. Left 1, down 1. Left 1, down 1, 2, 3. And left 1, down 1, 2, 3, 4, 5. Make the parabola. That is a nice parabola, Mr. Howe. Okay, in the linear equation, 2x minus 3. I can do that, no problem. Again, I might need to lightly make this one because the y-intercept is on the left side of the dotted, but this says clearly x has to be greater than 2. All right, so the y-intercept is -3, 1, 2, 3. I'm going to put a dot there, but that dot means nothing. My slope is 2, up 2, right 1. Still, that dot means nothing. Up 2, right 1. And now I'm right on the boundary line. And again, this should be open. It should be open there because it does not include it. It's only greater than. The slope again. Up 2, 1, 2, right 1. Up 2, right 1. Now I can make my line. Not the best line, but up 2, right 1 should be there. And there you go. All right. Now I can go back and I can erase these right here because those meant nothing. It was just only to help me get my line going. All right. That is a graph of the function of a piecewise function. Okay, we are going to talk about the vertical line test in the next video.